10 surprising facts about Kubernetes that you might not know. Kubernetes is written in Go. While many container orchestration platforms are built on Java or Python, Kubernetes utilizes Go, a language designed by Google for building system infrastructure. Go offers performance benefits and easier concurrency handling compared to traditional options. Namespaces are for isolation, not sharing. Namespaces are a core concept in Kubernetes, allowing the creation of virtual clusters within a physical cluster. Contrary to a common misconception, namespaces are primarily for isolating resources and workloads, not for sharing them across teams. Not everything needs to be containerized. While containers are the foundation of Kubernetes deployments, not every application component necessitates containerization. Certain microservices or legacy applications can still run as VMs, virtual machines on Kubernetes, if they don't benefit from containerization. The service mesh is not part of core Kubernetes. Service meshes, which manage communication between microservices, are often considered synonymous with Kubernetes. However, service meshes are an add-on layer that integrates with Kubernetes but is not inherently part of the core platform. Helm doesn't package applications. Helm, a popular package manager for Kubernetes, is often thought to bundle entire applications. In reality, Helm charts primarily focus on deploying configurations and Kubernetes resources, not the application code itself. The application code is usually built and containerized separately. Security risks lurk in YAML misconfigurations. YAML, the configuration language for Kubernetes, is a powerful tool but can be error-prone. Security vulnerabilities can arise from misconfigurations in YAML files, highlighting the importance of proper validation and security best practices. CRI Container Runtime Interface is the secret sauce. The Container Runtime Interface (CRI) acts as a bridge between Kubernetes and container runtimes like Docker or Containerd. This abstraction allows Kubernetes to remain independent of specific container runtimes, facilitating future advancements. Cluster operators are the new DevOps heroes. Cluster operators are Kubernetes extensions that automate lifecycle management tasks for specific applications or services. These operators streamline deployments, updates, and backups, empowering DevOps teams to manage complex applications efficiently. Serverless workloads can run on Kubernetes. While serverless computing is often seen as an alternative to containerization, Kubernetes can actually orchestrate serverless functions through integrations with frameworks like native or open FARs. The future is hybrid and multi-cloud. Kubernetes is not limited to non-premises deployments. It can effectively manage containerized workloads across hybrid and multi-cloud environments, offering a portable and consistent approach to container orchestration and